Hello friends and welcome to numerical integration. In this particular chapter you have to integrate and find out the area over a maximum range for a given function. Now why do we integrate? We integrate something to find out the maximum value of the particular instance or the formula given to us. In this case, let's see the first one, that is the trapezoidal rule. According to trapezoidal rule, you will be given a function always which will be carrying upper limit and lower limit, and this will be the function. We have been told to take 6 intervals, that is x1, x2, x3, and let's see how to solve. We have to again calculate the value of h, that is xn minus x0 divided by n. Xn minus x0 divided by n will be 3 minus 0 divided by 6. We get h is equal to 0.5. Let's see how to calculate the remaining solve. X0 will be 0, x1 will be x0 plus h, that is x0 will be 0 plus h will be 0.5, so it will be 0.5. x2 is x0 plus 2h, which is equal to 1. You can go on increasing in 0.5 steps because our step rate is 0.5. So you get 1.5, 2, 2.5 and 3 for x6. Now we have to find out y0. Similarly, y0 will always be 0 because the limit starts from 0. Calculating y0 is equal to 0. y1 will be 2x1 minus x1 square. x1 was 0.5. So substituting the values, 2x minus 0.5 square is equal to 0.75. y2 is equal to 2x2 minus x2 whole bracket square, which will be 1. Similarly, y3 is equal to 2x3 minus x3 whole bracket square, which will be 0.75 again. y4 is 2 bracket 2 minus 2 bracket square, so it will be 0, that is 4 minus 4 is equal to 0. y5 is equal to, not the y5 we use, y5 is equal to 2.5 minus 2.5 square, which is equal to minus 1.25, and y6 is equal to 2 bracket 3 minus 3 square, which is equal to minus 3. So we have all the values for x and all the values for y. We are interested only in the values of y because this will be useful and not the x values in the remaining calculation. So now we have the formula for a, and this formula for a is almost similar for all the integration rules except the fact that the values change and the placements change. So a is equal to h upon 2 big bracket and smaller bracket, y0 that is the first value, y6 that is the last value, plus 2 into y1, y2, y3, y4, y5. We do not consider y0 and y6 because they are already considered. So 0.5 divided by 2 bracket 0.0 plus minus 3 plus 2 bracket 0.75 plus 1 plus 0.75 plus 0 plus bracket minus 1.25. So calculating this term first, then calculating this term and multiplying by 2, and then adding both the terms. So 0.5 divided by 2 will be 0.25, and then multiplying 0.25 to whole term, we get minus 0.125. This is your final answer. Unitless answer because no units were mentioned initially, and area may be negative, may be positive in the coming integration, so do not worry about the answers. I hope you got the steps. We first found out h. From the h we calculated values of x. From the x we calculated values of y. From the y we put it in the formula of area and found out the areas for the corresponding calculation. Let's see the next numerical. This is Simpson's 1/3 rule. Now similar to the trapezoidal rule, this calculation has the similar steps like the trapezoidal rule, except the fact that the formula for area changes. Let's see how to solve. You have been given 0 and 0.8, that is xn and x0, the limits. You have been given the formula, and always remember, in this particular formula or function, sine term is involved. Whenever sine term are involved, put your calculator into the radian mode compulsorily, or else all your answers will be wrong and you will be given 0 marks for all of this calculation. Whenever sine, cos, trigonometric term appear in your calculation, always put your calculator in the radian mode as soon as possible to avoid any mistake for further calculations. Now xn is equal to 0.8, x0 is equal to 0, and the number of strips we were given, or the number of steps we were given, is equal to 8. So h is equal to 0.8 minus 0 divided by 8, which is equal to 0.1. Next, calculating all the values of x, x0 will be 0, x1 is x0 plus h will be 0.1. Now the step size is 0.1, so 0.2, 0.3, 0.4 till 8, 0.5, 0.6, 0.7, 0.8. We got all the values of x. We are interested in the value of y, so y0 will be 0, putting the values in x. Now log this you have to consider as ln in the radian mode. X plus 1 plus the rest will be the same. So y1 is equal to ln x plus 1, x1 plus 1 plus sine 2 into x1. Putting all the values of x1, that is 0.1. So ln 0.1 plus 1 plus sine 2 into 0.1 will give you 2939. I have mentioned radian mode. Do not forget the radian mode compulsorily. Y2 will be putting ln y2 plus 1 plus sine 2 into x2. So putting the values of x, you get 0.5717. y3 will be putting the values of x3, y4 will be putting the values of x4, y5 will be putting the values of x5. Putting all the values, you get y and x values respectively. Area should be h by 3, unlike h by 2 in the trapezoidal rule. So h by 3, y0 plus y8, that is the first and the last term, plus 4 into y1 plus y3 plus y5 plus y7, that is in the bracket. All the odd terms will go with the even number, and all the even terms will go with the even numbers in Simpson's 1/3. So 4 with all the odd terms and 2 with all the even terms. Putting all the answers or the values in the particular equation for formula and calculating it singularly, that is adding these terms and multiplying by 4, adding these terms and multiplying by 2, adding these terms and dividing and multiplying by h by 3, and then adding all of them, you get 0.7725. Do not rely on your calculator for calculating. Calculate it singularly, because the chances for miscalculating are more and you may lose marks. Let's see Simpson's 3 by 8, which is the last and the final integration we'll be seeing in this session. It is very simple and pretty similar to Simpson's 1/3. Let's see what it is. So this is the Simpson's 3 by 8 rule integration, in which a function will be given, upper and lower limits will be provided. You have to calculate the step size, and from the step size we have to calculate x1, x2, x3, x4, x5, x6 till the term we have been given to find out. For example, if we have been told to find out 6 steps, that is x1 to x6 will be our step size, and y1 to y6 will be the step size. The only change where occurs in this Simpson's 3 by 8 rule is the formula changes, that is 3h upon 8, y0 plus y6, that is first and the last limits, plus for the odd numbers, odd number will be there, and the last term, which is pretty interesting, is the mid of all the remaining terms subtracting y1 and y6. I'll tell you how. You consider y1, y2, y3, y4, y5, y6. So these two terms will be in the first column. 1 2 will be with the odd number 3, and the remaining middle term will be with the number 2. So here you have to keep in mind that 1 by 3 has both even numbers, and 3 by 8 has one odd and one even number. You have to always remember that these are the odd numbers, and with the odd number in 3 by 8 and the middle term with the even number. In the previous numericals, odd were with even and even were with even numbers only. So putting all the values in the equation and calculating separately, I repeat, do calculate them separately, you get 0.1250 for this particular numerical. Do try to solve this numerical, and if any queries are present, do comment. I'll try to solve them as fast as possible. Apart from these numericals, you get 3 flowcharts to solve for the corresponding 3 numericals you solved. Do practice the flowcharts very precisely, because in examination they may grant you 6 or 8 marks very easily, and the flowcharts are very simple. Let's revise what we actually do in the integration. We are given x0 and xn. We calculate h. From the h, we calculate the values of x0 to the number of strips. From these, we calculate y, and then we put it in the area. So this is pretty much it for interpolation. In numerical integration. We'll be seeing more of these sums in the next session. I hope to see you in the next video. Thank you and keep subscribing.